So we start up with our input, which was equal to x, and then we squared it, we times it by itself. Put the r in and get an answer out, and we get our outputs. Here it comes, output, and that will equal x squared once we're done. Now I'm going to give it a different name. I'm going to call it f. Alright, could call it Fred, call it Charlie, whatever you like. Be a bit long-winded, but we'll stick with letters f. So f is such that x goes to, here we go, we started with x, and it becomes x squared. And if we just draw a sketch of what sort of graph we get with this, if you remember the plotting, you should all know what an x squared graph looks like. So I've missed, so let's just rub that out. Try again. Get something a little bit better than that. Right, where's my cursor? Let's put it there. And here we go. A little bit better, closer to an x squared. So we've got y equals f of x here, and f of x is x squared. So here we've got our y values, and here we've got our x values. Remember what I said before? I'm going to just put them in different colours. I'm going to call the domain blue. So the domain is our input. So the domain is down here. Domain is everything we can put into our function. Right, all the x values that go into our function. So there's our domain. Let's just get another colour. I'm going to go for green now. That's a little bit green, it's different. We have not had it on there. And that's going to be our range. And range is what we get out. So the range is on the y-axis. Y values are what we get out of the function. So here is our range, and we can see different values mapping onto the same thing. Alright, and we can see we're getting all unique values. Now, interestingly enough, our range doesn't go down below the x-axis, so we can describe our range. We've got a limit, and we can also describe our domain. So let's just describe, using mathematical language, describe our domain for both of these functions and a range for both of these functions. So let's just start off with the domain. So the domain for this function, x goes to x plus 2, well, everything can be in the domain. So we're going to say, we'll put some brackets to highlight the expression, x is such that x is a member of the reals. This little symbol here means is a member of. And I'll double line this, and this means all the real numbers. If a number can be positioned on a number line, then it's a real number. So all numbers like 1, 2, minus 2, square root of 3, pi, they're all real numbers. So all these numbers can be put into this function and get us our domain. Now let's look at our domain for this one. Now, what x values can we put into here? Well, again, we can put any x values. So similarly, x is a member of the reals. All x values can be put into this, and that gives us our domain. Now let's look at the range. Okay, let's go for a different colour, and we're going to talk about range. Sorry, didn't select the different colour. Do it again. Rub this out, and let's just talk about range. So range. Okay, we're looking at the y values, and the y values in this one, well, we can get every single y value out. So all the y values are in our range, and therefore the y values are all reals. Let's just draw that R a bit better. Okay, we put the double line there to illustrate we're talking about the group of the set of real numbers rather than just some arbitrary variable called R. Right, so it's a set of real numbers, not very well drawn, unfortunately. We're going to talk about the range of this one, and we know that it's a bit more limited. Okay, y is going to be such that, well, we don't have anything less than 0. 0 squared is 0, and that's the lowest value we're going to have on this. So therefore, y must be greater than or equal to 0. Okay, so that is the range of our function here. Okay, this one any number could be got out. When this one we are limited to just y is greater than 0. Now, what I'm going to look at next is what happens when we combine these functions. Okay, and this is called a composite function. So let's look at composite functions. So let's go back to our machine. Now let's just say we did square the function. Let's just see if I can get rid of that, and let's just bring another operation, and then we added 2. So we have 2 functions here. So we square the function and then we add 2 to it and we get a result out. So we put in 1, get 1 times 1 is 1, plus 2 gives you 3. Not a very good example, so let's just get something that changes after the multiplication. Let's put 2 in. X equals 2. 2 times 2 is 4. 4 plus 2 is 6. So here we go, we're going into the function, I think we called it f first, and then we called this function g next. So you take the answer from here and you put it into here, and then you get an answer out. So let's look at how we go about writing that. So our 2 functions were, let's check on being consistent, so we've got g and we've got f. So we have g, let's just take this and do g of x is equal to x plus 2, and f of x equals x squared. Now what we were doing was we were taking this and put it into here, into g of x. So we took the f function and put it into the g function, and we got gf of x. Now the best way to write this is to write gf of x. Now this is very confusing how to do the order, because remember what we did, we put it into f first, then we took it from f and put it into g. So this means we do f first followed by g. So let's write that out. G f of x is equal to x squared, so put x squared in for f of x. Now we want to put that into g, so we take this x squared, put it into g. So the x becomes x squared, so we get x squared plus 2. So the answer to this is x squared plus 2. Now if you look at it in the other order, let's look at doing g first. So we're going to do f g of x. So we're putting the result of g into f. So we've got g of x, which is x plus 2, and we're going to put that into f. So fg of x means we do f of x plus 2. So we take that x plus 2 and put it into f of x. So where the x is, we put the x plus 2. So put the x plus 2 in for where the x is, and what do we do to the x? We square it. So all of this is going to be squared. So therefore fg of x is equal to x plus 2 all squared.